This is our last quiz for our pre-calculus curriculum, and it's going to cover actually all of Chapter 11. So I know Quiz 7 covered part of 11.1, dealing with our distance and our midpoint formulas, but the end of 11.1 was dealing with circles and your standard equation of a circle. And so I wanted to put a question like that onto the quiz 8. So that's actually our first question, which we will tackle in a moment. 11.3 deals with ellipses, which is a sort of flattened circle. I can very quickly show you. That's an example of an ellipse or like that. Think of ovals. And then 11.5 deals with systems of non-linear equations. Let's jump into our first question. We want to show that this equation represents a circle, and so we're asked to find the center point and the radius. So think completing the square 2 times. We have 2 different variables, so I'm going to pair my x's with one another and then leave some space for that manipulative constant that we will add to both sides. So we have our x squared plus 4x, and then leave some little space. And then we have plus y squared minus 6y, leave a little bit of space. And then I'm also going to move that 12 over to the right-hand side by just subtracting 12 on both sides. Okay. Now, every time we complete a square, we need to think of our special key for completing the square, which is just our b over 2 in parentheses squared. And that b value is just when you're thinking about your general equation of a quadratic, a squared plus b squared. What am I doing? Ax squared plus bx plus c, where that b value is very easily identified now that we're just comparing the forms. It's 4 for our x, and then it's -6 for our y quadratic. So maybe I'll put that off to the side as well. Okay. So we're looking at 4 divided by 2 in parentheses squared, which is just 2 squared, which is 4. That's what we are going to add to both sides of the equal sign so that we are manipulating it and keeping everything balanced. Whereas for our y's, we have -6 divided by 2 in parentheses squared, which is -3 in parentheses squared, which is 9. So we are going to add 9 to both sides. And now it's ready to be factored. X squared plus 4x plus 2 is the same as just x plus 2 in parentheses squared. And then y squared minus 6y plus 9 is the same as y minus 3 in parentheses squared. And then let's add up what we have on this right-hand side. 9 plus 14 is 13, and 13 minus 12 is 1. So there we have it. We officially put this into our standard form for an equation of a circle, our x minus h in parentheses squared plus y minus k in parentheses squared is equal to r squared, where our r, if r squared equals 1, take the square root of both sides and we get our radius to be 1. As distance is always positive. And our center point is just, this is a plus 2 and this is minus h. Our h is then -2, and then our k is +3. So -2, comma, +3. And this completes our question 1. Question 2, now we're looking at an ellipse equation, and we're asked to write this in standard form, and I gave you the standard form for the ellipse just to be helpful for this question. However, what are we doing here? We're again going to use some manipulation of completing the square twice. It's just now we want to get it into a slightly different form. So we have 4x squared plus 25. I think I'm going to pair all my x's right now together, plus 8x, and then leave a little bit of space. And then we have plus 25y squared plus 100y. Leave a little bit of space, and then bring that 4 over to that right-hand side. Okay. Also, this x squared over a squared plus y squared over b squared equals 1. If it doesn't stem from the origin, you can actually look at it as our x minus h in parentheses squared over a squared plus y minus k in parentheses squared over b squared is equal to 1. Okay. All right, so the first thing when you are completing a square is you want to make sure that your leading coefficient of your highest degree is 1. So let's first hone in on that 4x squared plus 8x. And what I'm going to do is I'm going to divide everything by 4 to make that 1. So I'm going to divide this whole by 4, all this by 4, and even that right-hand side by 4. So we're essentially looking at x squared plus 2x, leave a little space, plus our 25 over 4y squared plus 25y, leave a little space, is equal to -1. Okay. And now let's use our special key in order to complete the square with our x. So our b value is 2. So we get 2 divided by 2 in parentheses squared, which is just 1 squared, which is 1. So we're going to go ahead and add 1 to both sides of our equal sign to keep everything balanced. And now we're ready to complete the square with what we have highlighted in pink. This is just x plus 1 in parentheses squared. We're good. Okay, now we have to manipulate all of this. And again, we want to make sure that our leading coefficient is 1. So how do we do that? We are going to go ahead and divide everything by 25 over 4. We still have to divide this by 25 over 4. And we need to divide this by 25 over 4. But lucky for us, that's actually just going to be 0 because -1 plus 1 cancels out. So let us simplify this. 25 over 4 divided by 25 over 4 is just 1. 25 divided by 25 over 4 will keep change flip, and this just becomes 4, right? 25 over 1 times 4 over 25. The 25s cancel out. So we're essentially looking at plus y squared plus 4y. Create a little bit of space. And then all of this shoots to 0. So equals 0. All right. Now we are ready to complete the square with our y's. Our b value is 4, so 4 divided by 2 in parentheses squared is just 2 squared, which is 4. That's what we are going to add to both sides of the equal sign. And so now we are going to add 4 to both sides of our equal sign in order to balance everything out. And so now we are ready to factor out or factor y squared plus 4y plus 4. That just factors into y plus 2 in parentheses squared. And then we can finish writing, or we can just copy and paste the x down here. I'm going to actually highlight this part in yellow so you can see that we just factored that quadratic into a binomial squared. And this is equal to 4. Now, our very last step, until it starts looking a little bit more adequate, is we want this right-hand side to be 1, so we're going to go ahead and divide both sides by 4. And when we do that, you'll notice that this will look a lot cleaner. 25 over 4 divided by 4 is the same as divided by 4 over 1. And so, does it cancel out? No, it becomes 25 over 16. Let me just make sure I did that correctly. Yeah, I did that incorrectly. So let's first simplify this top part. When you keep change flip your x plus 1 squared, it's going to look like x plus 1 in parentheses squared over 1 times 4 over 25. So we can actually rewrite this where the 4 is in the numerator and 25 is in the denominator, and then it'll look a little bit cleaner. So we have our 4 in the numerator, 25 in the denominator, and then we divide it by 4. And then let's do keep change flip again, and that's where you could see you have this whole fraction divided by 4 over 1. Keep change flip is the same as multiplying this by 1 over 4, and so the 4's cancel out. Let me shrink this so we have some more space. Right, it's much better. Let's zoom in now on this. So I just showed you guys that by keep change flip, our 4's will cancel out. And then what we're left with is x plus 1 in parentheses squared all over 25 plus y plus 2 in parentheses squared all over 4 is equal to 1. And there we have it. We have officially put our general equation of our ellipse into our standard form equation. I think what I'll do is I'll copy and paste this right here. Right? Very easily, you're able to identify your a squared. If you wanted to write this as x plus 1 squared over 5 squared, so you can really see what your a and your b values are, plus your y plus 2 squared all over 2 squared is equal to 1, you would get full credit for this as well. And we're done. Let's move on to our question 3, where we're asked to graph the ellipse x squared over 25 plus y squared over 36 is equal to 1. So what's our a value here? Our a is equal to plus or minus 5, right? It's just the square root. If a squared is equal to 25, just take the square root. Our b squared is equal to 36, which tells us that our b is plus or minus 6. And our h and k is 0, so we're stemming from the origin. That's our center point. Okay, our a represents along our x-axis since we're stemming from the origin, so we just go to -5, plot, +5, plot as our x-intercepts. Our plus or minus 6 for our b are just our y-intercepts, so +6, plot, and then 1, 2, 3, 4, 5, -6, plot. And now we just want to create our ellipse. Try my best. That was a circle. Let me try and fix this. And there we have our graphed ellipse. We should probably write out the intercepts and label it. So we're gonna label it our x squared over 25 plus y squared over 36 is equal to 1. And then our x-intercepts, we have 5, 0 is an x-intercept. -5, 0 is our other x-intercept. And then our y-intercepts, we have did I plot it correctly? A is 5, yeah, 6, good. This looks like 5, but it's 6, 0, 6, and then 0, -6. Perfect. Finally, our question 4. We want to solve these systems of equations that are not linear. Actually, in both cases, we are dealing with a quadratic, and then we're dealing with a circle. And so let's use elimination to solve this. I'm going to actually, maybe I'll write the equations off to the side over here. X squared a little larger so you could see it, and x squared minus 2y equals 4. I'm going to just subtract the bottom by one another. So x squared minus x squared cancels out. And then we're left with negative y squared. Don't forget to use distributive property. So we get negative y squared plus 2y on that left-hand side. And then 1 minus 4 gives you negative 3. I personally don't like negatives. So what I'm going to do is I'm going to move these guys over to my right-hand side. And so when I do, I'm left with y squared minus 2y minus 3 is equal to 0. And now we can factor this. What are factor pairs of negative 3 that add to negative 2? Just negative 3 and positive 1. So y minus 3 and y plus 1, which tells us that our two y values are just negative 1 and positive 3. Now let's plug these back into either one of these equations to figure out all of your potential x values. So I'm going to create maybe a little t-chart here when y equals negative 1 versus when y equals 3. Does not matter which equation you use. I'm going to go ahead and maybe use the second one. And so we have x squared is equal to, I'm going to bring that 2y over to the right-hand side. So 2, and our y is negative 1, plus 4, which tells us that we have x squared is equal to negative 2 plus 4. So x squared is equal to just 2. And then when we take the square root of this, we get two potential solutions. We get positive square root of 2, and then we get negative square root of 2. Which means our two coordinates, when y equals negative 1, we get positive square root of 2, comma negative 1. And we get negative square root of 2, comma negative 1. Okay. Now let's look at our solutions when y is equal to positive 3. So x squared is equal to 2 in parentheses now positive 3 plus 4. 2 times 3 is 6. 6 plus 4 is 10. Then we're going to take the square root of 10, which cannot be simplified. And so we have x is equal to plus or minus the square root of 10. And so this tells us that our two coordinate points when y equals 3 are the square root of 10, comma 3, and this negative square root of 10, comma 3. And there we have it, our 4 solutions to these systems of nonlinear equations. So I'll just fill that in right now. So I don't know if the snap worked, but I tried to do that. There we have it, our 4 solutions. I also boxed it in green up here so you could see that those were the solutions that I transferred down below onto our little answer key. This completes our quiz 8. Let me know if you have any questions, and congratulations, you completed all the quizzes for this course. All right, take care, everyone. Bye.